this one, this part, sodium of sodium hydroxide and chlorine of hydrochloric acid, they join together to form sodium chloride, which is the salt. You know that. The salt we eat. And then H and OH join together, these two, to form what? H2. Make sense? So that is water. So you see these two chemicals are exchanging their parts, right, to produce new chemicals. So that is an example of exchange reactions. Organic and inorganic compounds. Important inorganic compounds in the body are water, salts, acids, and bases. Water is the most common or abundant chemical, and it belongs to inorganic. It is not organic. Okay? Salts, acids, and bases. Organic compounds are proteins, carbohydrates, fats, and nucleic acids. Those four are organic compounds. Okay? Organic compounds have plenty of carbon. All organic compounds have carbon atoms. Inorganic compounds may not have carbon in its structure. So that's why when we see the chemical formula of an organic compound, we see carbon atoms. Many carbons are there, okay, connected by covalent bonds. First, we will talk about the inorganic chemicals. Water is the most important, most common. About 60 to 80% volume of living cell is given by water. So the body cells are mostly water, and your body is mostly formed by water, right? You know that. Sorry, it's water. So water is 60 to 80% volume of the living cell. Now, important properties of water. Water has some very important properties that helps in our survival. One is called high heat capacity. What is this? High heat capacity means water can hold a lot of heat inside it. Can hold a lot of heat inside it. And it does not get cold or hot quickly. That is very important. It doesn't get hot or cold quickly. Make sense? Because it can hold a lot of heat in it, so you won't be able to make it hot quickly, not cold quickly. So now, how that helps you all know. If you go outside in mid-winter night, when outside is very cold, right? Without enough clothes, outside temperature is very low, right? If your body quickly turns to very cold, then you will die, right? But that doesn't happen, right? Because your body is water and it doesn't turn to cold quickly. Make sense? It takes long time to get it, the water cold. Now, if you go to Las Vegas, Death Valley, where temperature is 140 degrees, right? If you go outside of your car, if your body water turns to very hot quickly, immediately, right? Then you will not die. You will not survive. You know that if body temperature goes to 140, right? no way you can survive. So that doesn't happen because water has high heat capacity, high heat of vaporization. To turn water to vapor, you need to add a lot of heat, and therefore the body water doesn't turn to vapor. If that happens, then you will disappear. Your body will shrink immediately because if water leaves quickly, right? So that doesn't happen. Major transport medium. We know that blood transports the chemicals from one place to another. Blood is the main transport medium, and blood is mainly water. Main component of blood is the water. So many chemicals are dissolved in water, and when water moves, blood moves, those chemicals are transported from one place to another. Water is necessary for hydrolysis and dehydration synthesis reaction. Not only that, you remember in last class I told you that if you put two dry chemicals together, right? Chemical reactions usually doesn't happen. Okay. But if you dissolve them in water and mix them, chemical reactions, the chance of chemical reaction is very good, right? So chemicals must be dissolved in water for the chemical reactions in your body, and the body water helps in it. That is how the water helps in chemical reactions. But water directly participate in some chemical reactions. Those are called hydrolysis. In that chemical reaction, water breakdown occurs. And in some chemical reactions, synthesis of water occurs here. For example, this one. In this one, after the chemical reaction is done, we are getting what? Water, right? So in some chemical reactions, after the reaction, we gain water, and in some reactions, water breakdown occurs. So two parts of water get separated. So dehydration and hydrolysis. Okay? Dehydration synthesis. Synthesis is the production, and lysis is the breakdown. In these reactions, water participates, and most of the chemical reactions are helped by water because chemicals must be dissolved in water. Cushioning. Cushioning is giving protection to the important organs of your body. Like, tell me, what is the most important organ of the body? Brain, right? So around your brain, you have cerebrospinal fluid. Do you know that? CSF, cerebrospinal fluid, right? Around your brain. So this is the skull bone. This is the soft brain, right? And in between you have what? Fluid. That fluid is water, mainly water. Other chemicals are dissolved, but mainly water. So, when you move your head, we do that, right? Suddenly, the brain doesn't hit the skull because of that water around it, right? So, very important. Around all important organs of your body, you have fluid, which is water. Around your heart, you have pericardial fluid. Around your lungs, you have pleural fluid. So fluid is everywhere, okay, around the organs. Around your abdominal organs, you have peritoneal fluid. Have you heard that? Peritoneal fluid, protecting the organs, right? So they are not hitting each other, they are not rubbing each other because of that water. So very important protection. Okay, so those are the important properties. If I ask you, high heat capacity, high heat vaporization, transport medium, chemical reactions, and cushioning for protection. Okay. Now, what are other important inorganic chemicals? Water is the most common inorganic. Acids and bases. So let's very quickly go over the acids and bases. I am sure you have already learned in chemistry or in high school chemistry if you have taken acids and bases. Since these belong to inorganic compound of the body, we will talk a little bit about it. So, acids are the chemicals that can quickly release hydrogen ion. Okay. So, acids can quickly release hydrogen ion. Example of acid, HCl, hydrochloric acid. Okay, it is an acid. You know that? Have you heard that? Hydrochloric acid. Okay. So why it is an acid? Because it can quickly split and deliver hydrogen ion. Make sense? So that's why it is an acid. Another acid, let's say carbonic acid, H2CO3, another acid. Why this is an acid? Because it can quickly release hydrogen ion. Okay? So both are acid. Now, both are quick. Okay? Both can release hydrogen very fast. But if this one is faster than this one, this is stronger acid. This is weaker acid compared to this. Make sense? So who can produce more? That is stronger in 1 unit of time. Okay? This one is producing this many number, this one is this many. If this number is more, this is stronger, this is weaker. Make sense? So how quickly, how many hydrogen atoms are being delivered, depending on that, we determine the strength of that acid. Okay. Bases. Bases are the chemicals that can quickly release OH, hydroxide. For example, most ideal base is sodium hydroxide, NaOH. It's ideal base. Why it is base? Because it can quickly produce OH. That's right. Now, why bases produce OH? Bases produce OH to remove excess hydrogen ion in your body. Make sense? To remove what? Excess hydrogen ion in your body. The problem of excess hydrogen ion in our body is if hydrogen ion concentration increases, pH goes what? Down. More hydrogen means less pH. And less pH means what? Acidic. I think I mentioned in last class, right? When I talked about the urinary system, acid-base balance, right? Same thing. So, more hydrogen ion is not good, right? Normal amount is always good. If hydrogen ion concentration increases, pH drops and your body becomes acid. Okay? So now, excess hydrogen ion should be removed, right? From the body. Who does that? Bases. How? By releasing OH. Now let's see how. OH removes this. When hydrogen ion concentration increases in your body, bases will quickly produce OH, right? Because they can quickly produce OH. And this OH will bind with this hydrogen, plus minus, right? They will quickly join to each other to form what? You know that. Make sense? And once you get water, it is neutral, right? It is not harmful. So that excess hydrogen ion should be quickly released by bases from your body. And how? By producing water. Okay? Water is neutral. So that's the function of bases. Okay, so neutral pH is 7, which is water. If the pH goes below 7, it is what? Acidic, right? Above 7, alkaline. Okay. Here you see some household chemicals and their pH. So you see 7 is neutral in the middle of that color scale. Below 7, going towards red, that is acidic. Above 7, going towards blue, is alkaline or base. That's it. So we have talked about the inorganic compounds, water, acids, and bases. Those are what? Organic or inorganic? Inorganic. Make sense? This side? Those are important inorganic chemicals. Now we'll talk about the organic, because our body consists of both inorganic and organic. So organic compounds are carbohydrates, proteins, fats or lipids, and nucleic acids. Briefly, I will go over. Okay? If you see a carbohydrate molecule, it has CHO, carbon, hydrogen, oxygen. So nitrogen is missing. These three main atoms or elements form carbohydrates. If you see lipids or fats, it has CHO, or some lipids have CHO and P. So that is lipid or fat. This is carbohydrate. Carbohydrate, okay? And if you see protein, protein molecule has CHO and N, nitrogen. All protein molecules have nitrogen in it. So that's the chemical structure of carbohydrate molecule, fat or lipid molecule, and protein molecule. Now, carbohydrates could be three types depending on the size of the molecules: monosaccharides, disaccharides, and polysaccharides. Mono is single, so simple sugar. Most simplest form of carbohydrate I mentioned is glucose, smallest. So, example, glucose, okay, monosaccharides. Disaccharides are double sugar. So, two glucose molecules or monosaccharides join to form disaccharide. Example, maltose. So, disaccharides are larger than mono. And largest form of molecule of carbohydrate is polysaccharide. Example, starch, glycogen. I showed you several glucose molecules, they join together to form one larger glycogen molecule. Remember that? That is stored in the body, right? So, do you remember that? Synthesis reaction. Okay, so that is the largest form of carbohydrate molecule. Okay. Lipids. Three common types of lipids. Most common types of lipids are triglycerides or neutral fats, mostly present in the blood. That's why you will see doctors sometimes they ask you to measure your blood triglyceride. So triglycerides are the most common. Then phospholipids. Phospholipids are present in the cell membrane. Cell membrane is mainly phospholipid bilayer, double layer of phospholipid. So phospholipids are mostly present in the cell membrane. And steroid type lipid is used in synthesis of steroid hormones. You know, there are steroid hormones in the body. Those hormones are produced by steroid type of lipid. So that is how we type the lipids. Fatty acids. If you break triglyceride or TG, breakdown of triglyceride produces two things: glycerol and fatty acids. Glycerol and fatty acids. So fatty acids are present in the body in huge amount because it comes from triglyceride breakdown, and fatty acids could be two types: saturated and unsaturated fatty acid. Why one type is called saturated? If saturated, you have huge amount of hydrogen. So heavily filled with hydrogen. Okay. In unsaturated, you have reduced number of hydrogen, less amount of hydrogen in unsaturated. So this one is saturated with hydrogen. This one is not saturated. That's why it's called unsaturated. So now there are a few differences between saturated and unsaturated. Saturated fatty acids usually come from animal sources. Saturated come from what? Animal sources. From animals. Unsaturated usually come from plant sources. Okay? Plants. Make sense? Saturated fatty acids. Which one is good? What do you think? Probably you know it. Unsaturated is good, right? Saturated is not good. So why saturated is not good? Because saturated fatty acids have a tendency to get attached to the wall of the blood vessels. So make the blood vessels narrow. Makes the lumen narrow. Reduces the blood flow. So that is not good for the health and cause several diseases. So saturated fatty acids are not healthy. Unsaturated fatty acids are good. Now another difference is in normal room temperature, saturated fatty acids stay in solid form. Example, cheese, butter, those are saturated fatty acids. Make sense? So they stay in which form? Solid form. You know that. But unsaturated fatty acids in normal room temperature remains in liquid form. Saturated fatty acids are yummy, okay? Very delicious. Now, butter, cheese, those are, we know that, very delicious. Unsaturated fatty acids are not so delicious. Okay? So, I asked in one of my class that which one is your friend? Okay? So one girl said saturated. I said, do you know it can kill the person, can cause diseases? She said, yes, I know, but I love to eat. So if you love to eat, saturated is your friend. But no friend is good friend if the friend kills you. It can be a good friend or harm you. So anyway, so those are the differences between saturated and unsaturated. Okay? So it's the proteins. CHO and N. So if you see nitrogen, that is definitely protein molecule. Okay, nitrogen must be present in protein. Now, you must remember just a few minutes ago I told you that protein molecule is like a chain. Remember that? So amino acids, right? Small amino acids join together to form a protein, right? So amino acids produce protein. Now in human body we need 20 different types of amino acids. But many different types of proteins can be formed by those 20 amino acids, right? By even using 4 different amino acids, like 1, 2, 3, 4, I can form different protein molecules, right? Like if I join them like this, 1 protein molecule. If I change the order, like 2, move 2 here, 1 here, that is another type of protein, right? So I can change the order or sequence of amino acids to produce different types of proteins. Okay? So that's why we have many different types of proteins, but 20 amino acids. 10 of those 20 amino acids are called essential amino acids because your body cannot change those amino acids. You have to get exactly they are needed for the body from outside. So the food you take every day, right? In those food, those 10 amino acids must get into the body. Make sense? Because your body cannot change or produce them. Other 10 your body can produce. So those you need to get from outside, those are essential because you have to get them, essentially you have to get them, okay? In your food. So 10 are essential, 10 are non-essential amino acids. You all know, I have mentioned, I wrote on the board, I'm writing again. From outside every day we get what? Nutrients, that means the food, and oxygen. And metabolism uses them to produce what? ATP, that gives what? Energy. Okay, energy is given by ATP. That's the main purpose. Also, your body produces, by metabolism, produces good things and bad things. Remember that? Good things include a small amount of water is produced, heat is produced, these are good. And bad things are what? Carbon dioxide and metabolic wastes, other toxic chemicals, right? These are bad, these are good. And this is very important. The main purpose of metabolism is this. Why? Because ATP is used in many physiological processes, functions in your body, right? So just a few examples here. The top one is showing a cell membrane. In the cell membrane, you have gated channels. You have what? Gated channels. Or doors. To open the channel or door, you need what? ATP, right? Energy is needed. If I ask you to open the door, you need to push it, right? So, ATP. Muscle contraction is happening 24 hours. So, to contract muscle, you need ATP. To bring the chemicals together for chemical reaction, they must come close to each other, right? So, ATP is used for chemical reactions. So, those are just few examples. There are hundreds. Many different functions are helped by ATP. So ATP is essential. Okay. So on time. Let me pass the signature sheet against.
Right. Okay. Yeah, I'm sure you know.
Sign.
No, we just have them online.
Yeah, I saw those on the syllabus, I was like, well, let's put that on the other one, so good. That's really good.
Those are just the extra. You have to sign the sheet.
So I think just in the lab we have exams. Thank you. You're welcome.
Tyler? 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 Alan? Okay. Jared?
Yep.
Jessica?
That's me.
Okay.
Oh,
Who is Jessica?
I'm Jessica. Is there another Jessica?
Okay, Jessica Berry.
Oh, no, that's not me.
That's you?
No,
No.
I'm Jessica Cohen.
Jessica is not here. Okay. Angelina?
Here.
Jessica Cohen?
That's me.
Okay. Shelley?
Here.
Here?
I thought you said Jessica Berry. It's Jessica Bomarito.
Oh, no. I see Jessica. Yeah, sorry. Jared Berry. Jessica Pomarita. Yeah. So you are here, right?
Yeah.
Very good. Then Greer.
Here.
Okay. Marisa.
Here.
Madeline.
Here.
Next, Jen.
Here.
Courtney.
Here.
Courtney Kessler.
Here.
Ashley.
Here.
Okay. Mallory.
Here.
Good. Lily.
Here.
Maximilian.
Here.
Lauren.
Here.
Alexandra.
Here.
Jed.
Here.
Sorry. Mira.
Here.
Gabriel.
Here.
Josephine.
Here.
Laura.
Here.
Gabriel. Gabriel. Ratkova.
Here.
Gabriela. So A went down, so that's what I did. Okay. Last is Rachel. R-A-C-H-E-L. No? Or Rachel?
Oh, yeah, I'm here.
Oh, sorry. That's Rachel. Right. So, two parts got separated.
I
So.
normally get that for my last name, but not the first one.
Your last name is what?
My last name is Vogelsang, but a lot of people get really thrown off by the middle GE.
Oh, okay.
Yeah.
I should have dum dum.
So everybody, after you sign the sheet, you can take a short break, then come back so we can start the lab.